Well, ladies and gentlemen, let's talk about circles today. There's a lot of definitions to go through, so let's get to work. All right? Now, the radius of a circle goes from the center of the circle to the edge, which is the circumference of the circle. So that is a radius. The diameter goes through the center, but it goes to both ends of the circumference. So it touches the circle at 2 points, and it goes through the center. This is also called a chord, and you'll notice that in the next definition. But the diameter is twice the radius, or you can say to find the radius, it's the diameter divided by 2. Okay? Now, a chord will be a segment that connects 2 points on the circle. It can also be called the secant, and this is going to be important when you get into calculus, but for right now, we can also call that a secant line. A chord or a secant line touches the circle at 2 points, okay? Just like the diameter is a secant line or a chord because it touches the circumference at 2 points, okay? Now, a tangent line touches the outside of the circle, or it touches the circumference at exactly 1 point, and that will be a tangent, so that is called a tangent. And it does not go inside the circle, it touches the circle only at 1 point. Now, a central angle is an angle that has a vertex at the center of the circle, and this is your vertex is your V part. So this is your center, and that's the vertex, and that is called a central angle. An inscribed angle is inside the circle, but the vertex is on the edge of the circle. It is not at the center. So this is an inscribed angle, and it's inside the circle. Okay, ladies and gentlemen, so these are all definitions that we have to know. Now, what is a minor arc? A minor arc is named by 2 points on the circle, and it's an arc that is less than 180 degrees. Now, you know that a half a circle is 180 degrees because a whole circle is 360. So that's how you can tell you have a minor arc. So here is minor arc AB. It's less than 180 degrees. And we name the arc by a simple arc on top of the 2 letters. Arc AB, just 2 letters because that tells you it's a minor arc. Now, a major arc is named by 3 points on the circle, and it's greater than 180 degrees. So the other arc on this circle, which is arc ACB, that is greater than 180 degrees, so we call that a major arc. Okay, and now let's talk about the degree measure. The degree of an arc. We're not talking about the length in inches or measuring it. It is the degree measure. So we're using degrees, okay? So the degree of an arc is equal. The degree of an arc is equal to the degree of the central angle that makes the arc. So let's take a look at this circle. Let me just zoom in a little bit just to show us, all right? So let's take a look at this circle that I have. The circle that I have drawn here is, we have arc AB, which is a minor arc. The central angle is 80 degrees, so the arc will be 80 degrees, the arc degree. So we say the measure of arc AB is equal to 80 degrees, and they're talking about the degree measure. We have the measure of arc BC. Well, that is 50 degrees inside the central angle, so the arc is 50 degrees. So if I know that the arc is 50 degrees, I will also know that the central angle is 50 degrees. Now, the major arc, ADC, this is the major arc, is going to be 230 degrees. Because all of the angles inside a circle, they all have to add up to 360 degrees. So if I'm giving you 2 of them and we're missing this major arc, we can just subtract from 360. So 130, 360 minus 130 would give us the 230 degrees. So we can find that by knowing that all of the angles of a circle add up to 360 degrees. Okay, so let us move on, ladies and gentlemen. So now we're going to talk about an inscribed angle and the arc that it makes. An inscribed angle, here is an inscribed angle, the vertex is at the edge. The measure of the arc it creates is double the measure of the angle. So angle ABC creates arc AC, and so the measure of arc AC is going to be 50 because my angle is 25 degrees. Okay, folks? All right. Now this is another way to draw an inscribed angle, where you have a tangent line and a secant, believe it or not. Yes, that's still considered an inscribed angle. Okay? So the same rule applies. So if I take a look at angle ABC, it creates arc AB. Everybody see that? So if the measure of angle ABC is 60 degrees, then the arc it creates is going to be 120 degrees. Now let's take a look at the arc ABE. Well, this is angle ABE, which creates arc ADE. And if angle ABE is 120, well, you can tell if this is 60 and this is a straight line, you know that this angle is going to be 120. So you have to understand that. You've got to keep your information from previous geometry. So if this is 120 degrees and that's the arc it intersects, arc ADE, then that will be 240 degrees. Okay? All right. Let's talk about the point of tangency with a radius. Okay? Here is a tangent line, and the point of tangency is point T. The radius is drawn to the point of tangency of the tangent line, and when this occurs, it creates a right angle. Point of tangency with the radius creates a right angle. Done. So we can further say, if I connect the center of the circle with one of the endpoints of the tangent segment, I create a right triangle. So now I'm going to take this tangent line that was created, and I just didn't finish this. We just didn't take that piece. We just ignore that piece for right now because I'm creating a right triangle. If I connect this piece right here, we get a right triangle. And with a right triangle, we can use the Pythagorean theorem later on. Don't forget that. Okay, so let's do a couple examples here. All right, let's take a look at this number 6. If this is the arc that angle X intercepts, and that's 116 degrees, and this is an inscribed angle, then that X is equal to half of 116. So that's going to be 58 degrees. So X is equal to 58 degrees. Now, here we have an inscribed angle as well. This is an inscribed angle. It just happens to intersect a diagonal, which is half the circle. Well, this is half the circle. So if X will be half of 180 degrees, so we have a 90-degree angle. We have a right triangle right there. Okay, so don't forget that. Okay. So let's take a look at number 8. All right, now you can see it better, hopefully. There we go. Not too good. Let's try that again. Hopefully it'll do better. Okay, much better. Okay, so let's take a look at this angle X. Here is this angle. Well, we don't know what the arc that it intercepts is. What is the arc that it intercepts? We're going to figure that out. So we know that we have two other arcs. One is 82 and one is 60. So 82 and 60 is 142. So we know that the circle is 360 degrees. So we take 360 minus 142. Am I correct on that? That will give us a 218 degree arc. Okay? So this arc will be 218 degrees. Let's double check our math. 10, 4, 5, 6, 2, 3. Got it. So if that's 218 degrees, our angle is going to be 109 degrees, right? 109 degrees. So x is equal to 109 degrees. Now let's take a look at this beautiful diagram that has many inscribed angles. Okay? So we want to find A, B, and C. So here's angle A, here's angle B, and here is angle C inside. Okay, well, let's see how we can do that. Well, let's take a look at the arcs that we have. Here is the arc that intersects 60 degrees. And that is angle B. Angle B creates our 60-degree arc. Everybody see that? So angle B is going to be 30 degrees. So let's write that down. Angle B is 30 degrees. Okay. Now let's do angle A. All right, let's do angle A because angle A, here is angle A, and that intersects the 108-degree angle. Okay, great. So angle A is going to be equal to 54 degrees. So angle A is 54 degrees. So how do we find angle C? Well, if we know angle A and we know angle B, we can figure out what angle C is because the angles of a triangle have to add up to 180 degrees. So if these two add up to 84, then 180 minus 84 is going to give us 96. Am I correct? 96 degrees. So angle C is going to be 96 degrees. Again, you're using previous geometry information along with everything else that we're learning in circles. Okay? Don't forget all your basic geometry stuff. All right, ladies and gentlemen. So now let's take a look at our next piece of information here. Well, let's take a look at these two at the bottom first, okay? So if we have, this is an inscribed angle. This is angle W. And the arc that it intersects, or the arc that it makes, is this arc right here. And this arc is 246 degrees. So if that's 246 degrees, our angle is going to be half that, which is going to be 123 degrees. Done. Now, over here, for this one, we have Y, and we have 230 degrees, and we have to find angle X. Well, before we can find angle X, we got to find out what this arc is, because angle X makes that arc. But we know what this one is on this side. This one is 230 degrees. So if we subtract from 360, we're going to get Y. So let's take 360 minus 230. That gives us 130 degrees. So Y is equal to 130 degrees. And angle X is going to be half that. So half of 130 degrees is 65 degrees. So angle X is 65 degrees. Okay, folks, good job on that. So let's move on. We've got a lot more stuff to talk about. So in this picture, we're talking about when we create two tangent segments to the circle. From the same point that is outside of the circle, we are now creating an exterior angle, okay? So we have created also congruent segments. So when we have a point outside the circle and we connect that point, we create two tangent lines to the circle from that one point. The two segments will be congruent. So segment AB is congruent to segment CB. Now you're going to see that wonderful things happen because of this. All right? So we're going to go further to say, now let's draw the radii to the point of tangency. We know that from the previous pages, when we draw the radius to the point of tangency, we create a right triangle. We create a right angle. Now, if I connect the exterior point to the center, I have created congruent triangles, and they are congruent right triangles. So triangle AOB is going to be congruent to triangle COB. So that is going to be used later on in a lot of questions that you have to do. So please remember that. So let's take a look at these so that we can answer these questions, okay? So I want to find out what angle X is. Interesting. So what am I going to do here? Angle X. How do I find angle X? If the outside angle is 60 degrees, angle X, let's see what we got here. All right, so. All right, now, we know that this is 90 degrees because the radius goes to the point of tangency. So this is a 90-degree angle. We also know that this is a 90-degree angle, okay? This is a quadrilateral. It's 4 sides. So this is one way of doing it. There's other ways. So we can add our 90 plus our 90 plus our 60, 180, and another 60 is 240 degrees. But we know that the interior angles of a quadrilateral is n minus 2 times 180. So n minus 2 is 2 times 180 is 360. So all 4 angles have to add up to 360. So 360 minus 240 gives us a 120-degree angle. So that is equal to X. Okay? There's another way of doing that, but we'll hold off on that, okay? Now here we know that this is the point of tangency and this is a radius. So this is a right angle. Well, if that right angle is 90 degrees and that's 43, we subtract from 180. So 180 minus 90 and 43 is 133. So we get a 47-degree angle to equal X. Okay? Now, on this one, we have a right triangle again. This is the point of tangency, so that's a right angle. Now, this one you should remember from the Pythagorean theorem. If the legs are 5 and 12, that hypotenuse is going to be 13, so X equals 13. That's a special right triangle, a 5, 12, 13 right triangle. Okay, so remember that. All right. Now, on this last one here, we have the radius is X, and we know that this piece is X as well. This side is 12, and from here to here, it's 8. So how are we going to do that one? Let me see. Well, here we have to use the fact that we have a right triangle. Okay, we're going to use the Pythagorean theorem. So we're going to say x squared plus 12 squared is equal to x plus 8 in parentheses squared, because that's your hypotenuse. All right, so we have x squared plus 144 is equal to x squared plus 16x plus 64. Well, because we have the x squareds on both sides, when I subtract x squared, these will cancel out. So we're just left with 16x plus 64 is equal to 144. So we're going to subtract 64, so we get 16x is equal to 144 minus 64, which is going to be 80. And then we're going to divide by 16 to get x equals 5. I believe x would equal 5 because 16 times 5 gives us 80. So x is equal to 5. And we got our answer. Okay. All right, we're still not done. We've got a lot more to do, folks. Here we go. Let's find the angle measure of some angles made outside the circle. Okay? Now, here we have an arc ADC and we have an arc AC. Now, there is a point outside the circle and they're made with 2 tangent lines. Now, how do I find the measure of angle ABC? All right, let's see how we do that. There's a formula. You take the large arc, the major arc minus the minor arc, divide it by 2, and you're going to get the measure of angle ABC. And that is the formula that you use. So here we have the outer arc, which is 200 ADC, and the smaller arc, which is AC, which is 160. And we have 200 minus 160 divided by 2 to give us 20. Now, ABC, this angle ABC was made with 2 tangent segments. Now we're going to use the formula for exterior angle that is made by 2 secants. Okay? So here we have an exterior angle, and it is made by 2 secant lines. And we do the same thing. We're going to subtract I call it the outer arc, the one furthest away, minus the one closest. So the one furthest away minus the one closest divided by 2 gives you the measure of this angle. So this is 100 minus 44 divided by 2 gives you 28 degrees. Okay? So let's recap that. This one up on the top. When you have tangent lines making the exterior angle, it is the furthest arc minus the interior arc divided by 2. Same thing as down here, except it's made with secant lines. The outer arc, the furthest one away, minus the one closest, divided by 2 gives you the angle. Okay? Very good. Now, here is another rule that you need to remember. When 2 secant lines or 2 chords are drawn to intersect inside the circle, if they intersect inside the circle, we can use their angles to find the degree of the arcs or vice versa. So let's see what this is saying. So the measure of angle ABD, this angle right in here, angle ABD, is equal to the addition of the 2 arcs that are made by the 2 chords that intersect, divided by 2. So here you're adding instead of subtracting the arcs, and you're dividing by 2 to get the angle. Okay? So the measure of this angle ABD will be 120 degrees plus 40 degrees divided by 2 to give us an 80-degree angle. Now, this angle right here, angle CBE, is also 80 degrees because these are vertical angles, okay? So you have to remember that. So don't forget that as well. Let's take a look at some examples here. Here I have an angle that is created by a tangent line and a secant line, which is okay. Is an exterior line. We are going to take 160 degrees minus 68 degrees, divide by 2, and we get our angle. So this will be 160 degrees minus 68 degrees divided by 2, and we're going to get our angle. For this one, we have this arc is 120 degrees, but the outer arc that's not showing is 240 degrees, right, folks? We have to know that 360 minus 120 is 240. Now, the same thing applies here. We take 240 degrees minus 120 degrees, divide by 2, and you get your angle. Now, here we have an exterior angle, and it's made by 2 secant lines. And we're still going to subtract. We're going to subtract the 130 minus the 30-degree arcs, okay? So 130 degrees minus 30 degrees, divide that by 2, and you get x. Okay, ladies and gentlemen? And then for this one down here, we're adding, because we have an interior angle made by 2 secant lines that are inside the circle, and so we're going to add the 30 plus the 40, and we divide by 2, and that's going to give us our x. And I think I will leave the math up to you guys for all that. Okay, almost done, folks. Congruent chords have congruent arcs. It's as simple as that. So if these tick marks tell you that the chords are congruent, then the arcs that they intersect will be congruent as well. So here is segment AB. It creates arc AB. Here is segment CD. It creates arc CD. The two segments are congruent, therefore the two arcs are congruent. That's the symbol that means therefore in mathematics. Now, if you have two chords that are the same distance, here is two chords and they're the same distance from the center because those two tick marks tell you that. Therefore, the two chords are congruent. So you must draw the line segment to the center, creating a right angle. Again, the two lines that are congruent must create right angles because that's the shortest distance to a segment. Okay, so you have a right angle. This segment is congruent to that segment because it has a right angle. That tells you that because they're both coming from the center. Here is your chord. Here is another chord. And therefore, those two arcs are congruent as well. So from there, because the two chords are congruent, then the two arcs are congruent, and so arc AB is congruent to arc CD as well. Okay? All right, very good. Real quick on these three examples. Because we know that this segment is congruent to that segment, it's a right angle. And then these two arcs are the same measure because that is congruent to that, that's congruent to that. If this is 7, that's 7, so this is 7 and 7, so x equals 14. Good jobby. Now here we have right angles. So if that's at 8, this has to be 8. Those two arcs are the same measure, and x equals 8. Here we have 3.5 for this piece right here, and that is a right angle, and we have this segment congruent to that one, so obviously this one's going to be 3.5, and it is a right angle, so these two segments have to be the same. So if that's 5, so this whole segment is 10, so x is 10, so x equals 10. And that's it. With that, ladies and gentlemen, our circle section is complete. Good jobby.